Find the intervals of concavity as well as any points of inflection. For f of x is equal to 1/2 sine of the quantity 2x plus 5x on the interval from 0 to 2 pi. Let's get started. The first step is to find the second derivative and its critical values. So let's find the first derivative, and we're going to have to use the chain rule here. So f prime of x is equal to, we're still going to have the 1/2 there. The derivative of sine is cosine, so we have cosine of 2x, but then we have to take the derivative of this angle by the chain rule. And the derivative of 2x with respect to x is 2. And then plus the derivative of 5x is just 5. And then if we simplify this, the 2 and the 1/2 cancel out, so we just have cosine of 2x plus 5. Next, we need to determine what f double prime of x is going to be. So we have cosine of 2x plus 5. The derivative of cosine is negative sine. We keep the angle as it is, but then we have to take the derivative of the angle by the chain rule, and the derivative of 2x is 2. So then when we simplify f double prime of x, we will get the negative 2 times the sine of 2x. And remember, when we take the derivative of a constant at the end, the derivative of a constant is 0, so we don't have to put anything afterwards. Next, we have to determine when f double prime of x is equal to 0. So sine will be 0. I'll put it in terms of u for a second. Sine of u equals 0 when u is 0, pi, and 2 pi. Since our interval goes from 0 to 2 pi, it doesn't necessarily include the endpoints, but we do need to utilize them in order to get our intervals that we have here. So if we have u is equal to 0, then that means that 2x is equal to 0. So then x would be 0 there. We can also set 2x equal to pi. And when that's the case, x is going to be pi over 2. That does work. That's one value. Now we'll do 2x is equal to 2 pi. Solve for x, x is going to be just pi. That still fits within our interval. It could still happen. Let's go one more. We can also have 2x is equal to 3 pi. So x would be 3 pi over 2. So since our interval is from 0 to 2 pi, not including 0 and 2 pi, we can ignore this value because it's not included here. So we have a pi over 2, a pi, and 3 pi over 2. So that is where f double prime of x will equal 0. So that's again at pi over 2, pi, and 3 pi over 2. Next, we create a sign chart and test the values to determine the concavity in between these critical values. So we're going from 0 to 2 pi, and notice we have the open parenthesis here on both sides. And we're selecting points in between, but that are also still within our interval. If you remember when we were talking about absolute maxes and mins, I was saying in your sign chart you could put closed brackets on both sides as a reminder for where the interval begins and ends, and you can do the same thing here. So the point or x value that we chose between 0 and pi over 2 was pi over 4, and if we substitute that in, we'll have the sine of 2 pi over 4, or the sine of pi over 2, and sine of pi over 2 is 1, and negative 2 times positive 1 is negative 1, so we have a negative sign here. Then if we do 3 pi over 4, substitute that in for x, we have 2 times 3 pi over 4, which simplifies to 3 pi over 2. The sign of 3 pi over 2 is -1, and -2 times -1 is +2, so we have a positive here. And then for 5 pi over 4, if we substitute that in, 2 times 5 pi over 4 will give us 5 pi over 2, and the sign of that is the same as the sign of pi over 2, which is 1. And -2 times 1 is -2, so we have a negative sign here. And then when x is 7 pi over 4, 2 times 7 pi over 4 is 7 pi over 2. The sign of 7 pi over 2 is the same as the sign of 3 pi over 2 because it starts to repeat. It's going to be -1, and -1 times -2 is +2, so we have a positive concavity here. And after doing our sign chart, we can make the following conclusions. F of x is concave down on the interval from 0 to pi over 2 in union with pi to 3 pi over 2 because f double prime of x is less than 0. Negative frown, so it's concave down. F of x is concave up on the intervals from pi over 2 to pi and in union with 3 pi over 2 to 2 pi. It's concave up, looks like a cup, and is positive because f double prime of x is greater than 0. Therefore, f of x has points of inflection at pi over 2, and if we evaluate at pi over 2, we'll get the sign of 2 times pi over 2, or the sign of pi, which is 0, so this first term is 0 plus 5 times pi over 2, so it's just 5 pi over 2. So that's one point of inflection. Another one is pi comma 5 pi. Same deal. If we put pi in here, sine of 2 pi is 0, so the first term goes away. 5 times pi is 5 pi. And the last point of inflection is at 3 pi over 2, and when we evaluate that, it'll be 15 pi over 2. And this is occurring because the signs of the second derivative change from negative to positive and from positive to negative.